Some things we build not to show off, but to remind ourselves that our hands still remember. I've spent a lifetime with steel and sparks, the smell of smoke and the hum of old machines. There were times it worked, and times it burned, coils fried, wires melted, but somehow I always started again, because what I was making had a soul. Years ago, I shared a few ways to build homemade welding machines. Each one came from a story, back when tools were few and ideas were all we had. Lately, people have been asking, where are those old videos? So I brought them back, 3 homemade welding machines, each one built by hand, tested the hard way, shaped by patience and a bit of stubbornness. This isn't just a tutorial. It's a memory of a craftsman's life. If you've ever felt the thrill of that first spark, if you know the quiet pride of making something real, then stay a while. Maybe, somewhere in this video, you'll find a piece of that old feeling again, when work wasn't about money, but about the joy of bringing something to life with your own hands. For the first method, I'm reusing an old laptop charger that still works. The first step is simple. Split the output wire into 2 separate leads. These will later be used for the welding and ground connections. Just do it gently to avoid cutting the inner cores. Now we'll connect the 2 wires I'm holding to the ends we just prepared. I've marked them clearly. Red goes to the adapter's positive lead, and white goes to the negative. To keep things electrically safe, we'll use heat shrink tubing. Just slide it over the joint, apply some heat, and let it tighten around the wire. That's it. For extra safety, I'll slide on another heat shrink tube big enough to cover both wires together. That way the connection stays firm and neat. At this point, I'm going to test whether this old laptop charger still runs steadily. Keep an eye on it and watch closely. After plugging it into the power outlet, I'll check it with this voltage tester. That's the most reliable way to see if the charger is still working properly. The display shows 19.5 volts, exactly as printed on the charger. That means it's still working fine. I feel pretty lucky because all the effort up to this point hasn't gone to waste. For the end of the wire connected to the negative lead, I'll attach an alligator clip. Here's a tray with a few small metal pieces. Let's see if there's anything in here that catches my interest. A motorcycle valve stem. That looks promising. It might come in handy for this idea. And with one more piece from the cable turnbuckle, that's all I need. Now everything essential is ready. I want to fix this hollow valve stem onto the ring of the round head. At this point, I'm pretty sure some of you have already guessed what I'm up to, right? Well, it's time to lay it out. I'm building a homemade welding machine from this laptop charger. It's my way of turning something that looked like scrap into a practical tool. If you guessed it right, drop a comment below so I and everyone else can see how many of you figured it out. To be honest, once it's all assembled, the setup looks neat and pleasing to the eye. Now, let's set it down for the moment and move on to the next step. I'll remove the core of this battery pack step by step to turn it into a welding tip for the DIY unit. Watch each step closely. If you're new, observe first before trying it yourself. First, I'll clean off this battery core to get rid of the dirt, and then move on to the next step. At this step, I'll file down the sharp edges of one end of the battery core, making the welding process smoother and safer. Now I'll secure the welding tip to the valve stem. But first, we need to connect the wire, the one linked to the adapter's positive terminal, to the tip. Now we'll wrap tape around the wire near the handle, making it safer during welding by preventing direct contact with electricity and keeping the wire secure. If the tip of your welding piece still has sharp edges, file it down a bit to make it smoother and easier to work with. We're all set. Now all that's left is to plug it in and start testing. So that's it. The first method works. However, the welding tip made from a battery core is still a bit damp, so the reaction isn't very strong yet. We just need to let it dry for a while, and then we'll move on to the testing stage to see how well it performs. Now we'll fix this LED bulb by soldering over the damaged LED chip. You probably already know this. This is soldering flux. We'll apply a thin layer on the LED chip surface before using solder, so the joint bonds better and looks cleaner. As for this method of fixing the LED bulb, I've tested it many times before, so I can say with full confidence, it works 100%. Just follow the steps carefully, and the light will come back on perfectly. That's it. The first method is done. Now let's move on to the second one, which uses a different approach. Just as interesting. For the second method, I was a bit unsure at first. Using a spark plug would overlap with the third video, so I decided to switch things up a bit. What do you think? Starting with just a motorcycle valve stem. Pretty interesting, right? Here I've got a wooden handle already made, just the right size to fit comfortably in my grip. I'm going to use it as the handle for this homemade welder. Once the wooden handle is firmly secured in the vise, we'll drill a hole straight through it, size exactly to match the threaded body of the valve stem. Alright, the drilling is done. Now, let's set it back in the vise and get ready for the next assembly step. First step, remove the nut and washer from the valve stem. Sorry guys, I almost forgot. We won't mount the valve stem directly into the drill hole in the handle. We'll need a small extra part to secure it firmly. The part I'm talking about is this grinder flange. First, we'll attach the valve stem to flange, then secure the whole piece onto the wooden handle by driving screws through the two holes on the flange. I know the explanation sounds a bit rushed, but in just a moment it'll all make sense. It's a bit uneven, so I'll widen the hole slightly. Alright, let's drive the screws in and secure it. With the screws tightened, we can consider the handle part done. Now let's move on to wiring and attaching the welding tip. For this step, I've got a single core wire ready. Next, we'll thread one end from the bottom of the handle up to the top of the valve stem. With the wire fed through, we'll connect it to the welding tip. Feel free to drop your thoughts on my wiring method in the comments below, so I can learn a more effective way to connect. And if you think my approach works well, you're welcome to use it as a reference. I finished working on this end of the wire, and the only thing left is attaching the welding tip. But of course, it's best to handle the simpler step first, so I'll go ahead and connect the other end of the wire. For those who don't know, this is a crocodile clip, and we'll connect a wire to it. The wire connection to the crocodile clip is done. Now let's move on to adding the welding tip. If you've seen my previous welding videos, you're already familiar with using AA battery cores as DIY welding tips. The reason I go for them is simple. AA batteries have carbon rods inside that handle high heat, conduct steadily, and are easy to find around the house. By reusing them, we not only save money on specialized welding tips, but also gain convenience of quick replacements whenever needed. Their compact size makes them perfect for DIY setups, easy to mount and practical to use. All in all, it's a smart solution for anyone building a temporary welder to handle small to medium-sized metal repairs. You can see that removing the battery casing takes me a bit longer, but it's important to do it steadily and safely. Always protect your hands. Don't rush. I once hurried and ended up with a small injury on my hand. It wasn't serious, but what really stayed with me was the worried look in my daughter's eyes when she saw it. That's why I make sure to be more careful now. Alright, the battery core has been taken out and set aside in the cup. Now, let's move on to dealing with the metal casing of the battery. We only need this small piece to drop into the container with the battery cores. The rest can be discarded. To make the flux solution, get a bottle of toilet cleaner like this. Pour some into the container, holding the battery core and that small piece of metal. Did you know mixing a battery core with toilet cleaner and a small piece of metal creates a flux solution that cleans the surface, removes rust, improves weld bonding, and focuses the current at the welding point. This makes welding more stable, the joint stronger, and reduces splatter. A simple trick, yet very effective for a DIY homemade welder. After soaking for a while, I'll take the battery core out, dry it, and get it ready for use. I almost forgot. We should grind one end of the battery core to smooth out the edges, so it'll weld more easily. And there we have it, a DIY welding tip made from a battery core, now ready to be attached directly to the valve stem. With the tip attached, the device still won't work yet. Now we'll need to make one more tool. I had already made a wire with one end attached to a crocodile clip. Now we'll add another clip to the other end. English. I believe this step is truly challenging for anyone new to electrical work. Even a skilled electrician, if they jumped straight into practice without studying the theory, as I once did, would find it difficult to clearly explain the complex principle behind it. So I hope you'll understand. Of course, in this testing step, the small battery is essential. I recommend using a low power source, as that's what's suitable for this temporary device. And remember, don't connect the wires incorrectly. Even if the device still works, it will cause an unwanted opposite reaction. So, the second method worked perfectly too. See that? The flame burst up much stronger than in the first method. No surprise there. A car battery always delivers a lot more power than a laptop charger. And exactly for that reason, we'll take on a slightly tougher challenge. Let's see together if we can make it work. So the higher level challenge was successful. It just took a bit more time than the smaller experiments. Now, let's move on to the final method. For this final method, I've cut it down a lot to save your time. So stay with me and watch till the end to show your support. As for the welding tip made from a battery core, it's straightforward. I won't go into further details. The next step, I'll pick an old, hollow spark plug from this tray of spark plugs. The metal casing is still solid enough to hold the battery core. Careful selection ensures the finished welding tip is sturdy, easy to handle, and safer to use. Here I have a single electrical wire. We'll connect one end of the wire to the welding tip, and at the same time, secure the tip inside the spark plug body. To keep the wire from getting in the way while welding, we'll wrap a few turns of tape to secure it to the spark plug. This keeps the setup neat and ensures the welding tip stays firmly in place during use. The other end of the cable will be connected to a piece of metal to link it to the power source. This completes the circuit, allowing electricity to flow to the welding tip steadily and safely. This is the metal ring. We'll connect it to the other end of the wire. Here I have an additional electrical wire. We'll connect one end to the metal ring and the other end to a crocodile clip. To power the device, I'll use a specialized battery from a welding machine or drill. Its specifications are suitable to provide enough electricity for this DIY welding setup, especially if you don't have a car battery. No doubt about it, this method worked too. Stay tuned to see it in action. And that's it. All 3 DIY welding methods worked. Each one is different, from quick and simple to powerful, to creative use of old stuff. But all let you repurpose items, learn, and create something useful with your own hands. If you found this helpful, like, share, and subscribe to catch the next DIY tips.